Okay, this video is mainly for those people that were out today or people that want a little bit more time to check their homework answers from Thursday and Friday. So the first thing I have here is what we went over today from Thursday night. And I'm going to do just one or two examples here, probably just one from each of these just to kind of get you going on this. And then I'll show you the key as well because we looked at that today in class. So if you don't have any real rational roots, you must be given at least one imaginary root, or sometimes it's even an irrational root. In this case, we're giving you imaginary roots, and all you have to do is use synthetic division to divide and simplify down. So let me just show you how this would work. So one of the ones we did today in class was this one, and we know that if we have 2i in complex form, it's 0 plus 2i, which means it has a complex conjugate 0 minus 2i. So when I do the synthetic division, I'm going to do 2i, and then I'm going to also do minus 2i. And then I'm going to set it up to do my division. And remember, I showed you guys you could do it in the calculator. So I'm going to have a 2 as a coefficient, negative 2, 5, negative 8, and negative 12. And kind of spread these out to give you enough room to do what you need to do here. So go ahead and just bring down your 2. 2 times 2i is 4i. And then when I add these together, I'm really just adding the real with the imaginary. Well, this is only a real number, and this is only an imaginary or a pure imaginary. So I get minus 2 plus 4i. Now, what I'm going to do is show you what I'm doing in the calculator as well in just a second for that. And I won't show you every last time I do one of these, but I just want to make sure you understand how to do this in the calculator as well. So I'm going to have this negative 2i, negative 2 plus 4i times 2i. So once my calculator opens up, I'll show you that. And you're more than welcome to do this on the test as well, because we've already assessed you over this material on the last test. Okay, so I'm going to have 2i, so 2i, so 2, and then I hit the second button, and then I go down to the very bottom. It's like a little period button, and then I have, making sure I know what I'm doing here, it's minus 2 plus 4i, so minus 2 in parentheses, and then 4i again. And then this makes it a lot simpler to get your answer. So negative 8 minus 4i is what's going to go up here. So negative 8 minus 4i, and here I'm really subtracting these two reals. So 5 minus 8 is a negative 3 minus 4i. So now I've got to do 2i times negative 3 minus 4i. So 2i times a negative 3 minus 4i. And use parentheses there, and it gives me 8 minus 6i. So 8 minus 6i goes here, and you see that these cancel, giving you a minus 6i, and then negative 6i times 2i is negative 12i squared, which is really just a positive 12. So that cancels down to 0, which it should. And then I continue on, put a 0 here, add. 2 times negative 2i is negative 4i, and here these are canceling. When I multiply here, I get plus 4i. So these are canceling. I get a minus 3, and then I get a plus 6i, so this is a 0. Now, this is what I'm really interested in, because I already knew that I had roots that were 2i and a negative 2i. And you could also write that as plus minus 2i if you prefer to do it that way. What I really want to do now is use the quadratic formula here and find the other two roots, because remember I'm going to need 4 roots. So kind of just do this off to the side, negative b plus a minus square root b squared minus 4ac all over 2a. So my a is a 2, so put a 2 here and here. My b is a negative 2 here and there. And then my c is a negative 3. So I end up with, underneath this, the radical sign, it's called the radicand, it's 4, and then it's going to be plus 24. So that's going to simplify down to negative 2 is 2, plus and minus, remember I said it's 4 plus 24, which is 28, all over 4. And then the 28 will simplify down to 4 times 7. The square root of 4 is 2. So that's going to give me 2 plus and minus. And then all of this is going to be replaced with the square root of 2 times 7. I'm sorry, 2 times the square root of 7, all over 4. And then all three of these values, the 2, this 2, and this 4, are all divisible by 2. So when I do that division, I get this. So the other two roots are 1 plus and minus square root of 7 over 2. So I had 2 imaginary roots and I had 2 irrational roots. Okay? So what I want to show you now is the actual key to this. And if you need to pause the video so you can check your answers or kind of work through some of them, by all means do that. So this is the key for what we did on Thursday. And if you're out today, you missed this. So like I said, pause it right here and you can kind of work through some of these and make sure you're checking your answers. And then the next thing we did was we checked our answers from Friday night. So let me show you some from that worksheet as well. And we did several of these in class today as well. So I'm just going to pick and choose some, just making sure you understand how to do them. So I know that if I have a root of 3, I know I have a factor of x minus 3. And that's what this builds off of. So if I have a 3, I know x minus 3 is a factor. And then if I have a negative 5, I know x plus 5 is a factor. And I'm just going to multiply these together however you like to do it. So I like to do x times x, which is x squared. My outer is plus 5x. My inner is minus 3x, giving me 2x. And then here I get minus 15. So this is the answer to the very first one, f of x, because you're supposed to write it as a polynomial function. And then for number 2, I'll just set this one up for you. X minus 0 is really just the same thing as x. So we're not going to actually write x minus 0. And then x minus 2, and then x minus 4. I would probably distribute this, get x squared minus 2x, and then multiply that by x minus 4. So you would just multiply all that out. Then ones like number 4, I have an x plus 1, and then I have x minus the square root of 2 times x plus the square root of 2. And be sure to always multiply your complex conjugates first. Do this first. And then what happens is x times x is x squared. My outer is x square roots of 2. My inner is a negative x square roots of 2. So those cancel. So I don't even need to multiply those. And then the last is a negative square root of 2 times a positive square root of 2 is actually just a negative. Square root of 2 times square root of 2 is 2. So this is a factor. And then you multiply by x plus 1. And I'll let y'all finish that off. One other thing I needed to show you is if you have a situation where you have fractions like this right here. This is going to be x. This will be x minus 3 halves. And the negative 1 half will be x plus 1 half. But I want to show you a little trick so you don't have to deal with these denominators. You're going to bring it up front. So the 2 is going to come up front. This happens to be a 2. It's going to come up front as well. So this is going to be x and then 2x minus 3. All I did was bring that up front. And then 2x plus 1. And now you're not dealing with multiplying all the different fractions. It'd just be really yucky and messy. Okay, so take a look at that, and I think that should get you going. Just make sure you remember if there's a 2i, it means there's a negative 2i. Same thing down here, 5i, there's a negative 5i. And then you'll multiply these factors together first, those complex conjugate factors. Okay, now let me show you the key to this, and you can pause it here and kind of work on it some if you would like to do that. And let's see if I can get it where you can actually see it. Okay, so I want to make sure you can see all of it. I think that gets most of it. Okay, so pause the video there, work on it some, and then you can make sure you understand all those. Now, we also did a little worksheet today on word problems, and I'm going to get you started on that and just do a little bit with you there. So let me go to that worksheet. And I won't do all of this. I'll just kind of do one or two of them. Okay, I'm going to do number 2 with you. It's a really important one. And basically, on number 2, you want to write out your equation for volume. Well, volume is length times width times height. And we have our 3 dimensions here. So it's just going to be volume is equal to 2x, then x minus 4, and then x minus 1. And the order doesn't matter. Remember that multiplication is commutative, so order does not matter. I kind of like to put my monomial out front. That's just how I think of it. Now, I'm going to set this equal to 40. So I'm going to start by saying 40 is equal to 2x, x minus 4, times x minus 1. Now, to solve this, I'm just going to subtract 40 to the other side. So it's going to end up looking like this. So the left-hand side is just going to be a 0, but I'm going to put it in my calculator as like a little function. So I'm going to show you that part of it. So in the calculator, I'm going to do in the graphing feature. So go into graphing. I'm going to clear this out. So then I have 2x, and then I have x minus 1 times x minus 4 minus the 40. You have to set it all equal to 0. And then I'm going to graph it. Let me check my window real quick. That should probably work. And it looks like I have a root at 5. But remember, I can test it. I can do second, calculate. I'm just going to basically plug in the value of 5. And I definitely have a y equal to 0. That's the x-intercept. So going back to this, I know that I have x equal to 5. So now, to find the length, the width, and the height, so I'll just kind of do this here. 2 times 5 is 10. 5 minus 4 is 1. 5 minus 1 is 4. So let's just say the length is 2x. The width is 4. And the height is going to be 1. So make sure you know how to do a problem like that. And let me show you another one that's really important. Number 5 here. So I know 2 dimensions, but I'm missing the third one. So I know that if I had length times width times height, it's giving me this entire function here. So I know x plus 2 times x plus 4, and then let's just let this be the length here, is equal to 2x cubed plus 17x squared plus 46x plus 40. Now what I'm going to do is I really need to divide by both of these. I could multiply them together and then divide, but then I'd have to do long division. If I do it from right here, I can say this factor has negative 2 as a root, and this one has a negative 4 as a root. And I'm just going to stack it like this, like we've done in class. And then I have a 2, 17, so I'm just using these coefficients. And I have a 3, 2, 1. I have all terms present. And then I'm just going to do my synthetic division. So 0. Here I get negative 2, 15, negative 30. Here I get 6. Wait, that's not right. I've done something wrong. Oh, I should have a 2 here. This should be a negative 4. Sorry about that. I was trying to rush. And then here I get 13. And then I'll multiply that. I get a negative 26. I've still done something wrong here. And then I get 20 here. No, that was right. I'm sorry. And then when I do this, I get a negative 40. Now, I'm just going to speed up because I'm running out of time here. When you do all the synthetic division, you get a 2 here and a 5 here. That means that this missing is 2x plus 5.